A bullet of mass m strikes a pendulum of mass capital M with a velocity u. It passes through it and emerges with a velocity of u by 2 from the bob. Okay, the length of the pendulum is L. What should be the minimum value of u if the pendulum bob will swing through a complete circle? Okay, when it swings through a complete circle. Now, first of all, understand that. Let us assume there is a pendulum attached over here of mass capital M. There is a bullet which approaches it of mass small m. It approaches it with a velocity u. Okay, it approaches it with a velocity u in this direction. Okay, and it passes with a velocity u by 2. Okay, it passes with a velocity u by 2. Okay, let us first derive this part. Okay, let us first derive this part. I can say that mu, okay, that is the initial momentum. I can say that, otherwise if I write down the full formula, it will be equal to m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. Okay, plus m2 v2. Okay, over here the mass over here is equal to m, the initial velocity is equal to u. Okay, it will be equal to okay, u2 is equal to 0 because the pendulum was initially at rest. Okay, m1 v1, it is equal to u by 2 plus capital M into v. Okay, capital M into v, I will just write it as v. Okay, okay, so it will be equal to m into v, it will be equal to mu divided by 2. Okay, so I can say that v will be equal to small m divided by capital M into u divided by 2. Okay, let this be the first equation. Okay, let this be the first equation. We have to calculate the minimum value of u such that the pendulum completes an entire circle or just completes an entire circle. When it just completes an entire circle, I know that the minimum energy required or the total energy required or the kinetic energy at the bottom should be equal to, it will be equal to phi by 2 mgr. In this case, it will be equal to capital mg into L. Okay, this is the minimum kinetic energy at the bottom that is required in order to complete the circle. We have derived this in circular motion. Okay, so the minimum kinetic energy required at the bottom should be equal to phi by 2 mgl. So minimum kinetic energy required at the bottom, I can write this as half capital M into v square. Okay, that is the velocity at the bottom. You can clearly see the velocity at the bottom is v. Okay, it should be equal to phi by 2 capital M into g into L. Okay, so now m and m will get cancelled out. So we have to write down v square and 2 and 2 will also get cancelled out. Okay, 2 and 2 will also get cancelled out. So basically v square will be equal to m square divided by capital M square into u square divided by 4. It will be equal to 5 g into L. So u square will be equal to 20 gl into capital M square divided by small m square. This should be the initial velocity. Okay, when I take a root over here, u will be equal to root 20 g into L capital M divided by small m. Okay, I have written g twice over here. Okay, so it should be equal to 20 gl. Okay, it should be equal to 20 gl. Okay, capital M divided by small m. Let us see the option number over here. Okay, if you see from 20 I can take 4, I can write 20 as 4 into 5. So 2 will be outside the bracket. It will be equal to 2m divided by small m into root 5 gl. Okay, let us see which is the option number. 2m divided by small m into root 5 gl, which is option number A over here. So for this question, for the 53rd question, the answer is option number A.